So the question we are going to be solving here is the question has to do with how to calculate the temperature of a thermometer. The first one here is that the distance between the fixed points of a Celsius thermometer is 30 30 cm. And then so that what is the temperature when the mercury level is 14.5 cm above the lower mark. So let's start from there first. So when we look at that thing, we are going to be comparing the, the length and the true thermometer itself. Assuming this is the thermometer in question, the upper fixed point, we are meant to understand that the fundamental interval is 30 cm. The fundamental interval is the distance between the upper and lower fixed points. The upper, this is the upper, this is the lower. Now, so that the mark, lower mark, from this lower mark, mercury rise above the lower mark and then stop at 14.5 cm. So assuming we have a true thermometer, let's say the thermometer is the same, being the same length, we have our upper, which this is supposed to be 100 degrees C and this is 0 degrees C. Then we have a distance here. We need to find out what it's all about. Is that okay? So what we're going to find out is this the temperature that we have here. This temperature, now what is it going to be reading if we have a thermometer? If we have a thermometer that is already designed, that is already calibrated. So what we do here, we have 14.5 over what? 30. Then we'll come over to this place. What do we have here? We have here down there, since we don't know what we have here, what it means that T, the temperature we're looking for, subtract from 0 all over 100, subtract from 0. So when we subtract everything, what do we have here? We cross multiply T, 0 subtract from here, we have T, and then 0 from 100, subtract from 100, we have also 100. So when we cross multiply this, we have 1 and T multiply that, we have 30T. So the making T the subject of the formula, it will equal to 14.5 times 100 all over 30. So what we have next is that it will be equal to 48.3 degrees Celsius. That's the temperature of the reading of the word thermometer. So let's go to the second one. Let's go to the second one that we have there. So in this second one, it said that thermometer which was not accurately calibrated indicates minus 0.6 degrees Celsius at the lower fixed points and 107 degrees Celsius at upper fixed point. What temperature does the thermometer register when the true temperature is 70? So the first temperature we have here is the one that is not correct and has the upper fixed point to be what? 107 degrees Celsius, while the lower fixed point is what? 0 minus 0.6 degrees Celsius. And now we don't know the reading of this one. We call it T degree. T degree. So we don't know what we have there. The other temperature, the true temperature, is the one that has the accurate reading. Then 0 degree and 100 degrees Celsius. Now in this true one, in the true one, we say it's what? 70 degree. The 70, let me not look like 80. So it's 70. So what we do again is like what we have done in the past. We compare them. If we compare the whole thing, what we have here, we have this will give us T all over So when we cross multiply, if we cross multiply this, okay, let's finish it up here. Minus, multiply minus, we have t plus 0.6 all over plus 0.6 again. That will give us equal to 70 over 100. So this one, we will add it up. We have, okay, crossing over, we have t plus, that will give us this number 107 plus 0.6 will give us times 70. So the next thing we are going to do here is that we'll multiply through. We have 100t and then plus 60 equal to let's see what we have here. That will give us 7532. So then if we collect like terms, what we have here will be 7532 subtract from 60. Subtracting from it, we have 7472 equal to 100t. So making t the subject of the formula, we will have 7472 all over 100. So by dividing, we have 74.7 approximately. That's the actual works temperature of this. So we can also look at the other type of thermometer that has to do with resistance. The resistance thermometer. So in this one, we are going to be looking at the resistance thermometer and that of gas thermometer, how to calculate them. The first one is resistance thermometer. I said that the resistance of a platinum is 6.795 ohms at the temperature of steam at 760 millimeter mercury and 6.3050 ohms at the temperature of melting ice. If the resistance at the temperature of the warm water is 6.5 ohms, calculate the liquid temperature. So let's start with that. So for us to do this, the first thing we do is that we're going to be using the formula for that. The formula we can always use for this. The formula is what? T equal to that is the resistance at T and then minus resistance at 0 and then resistance at 100 degree minus resistance at 0 times 100 over 1. That is to give us degree, 100 degree over 1. So this formula or the relation is what we are going to use in solving this problem. That's what we're going to do. So the resistance or the temperature we're looking for is what? We have it to be what? 0.6.5. We can say 6.5. That of 0, melting ice. Melting ice is what? 6.35. We can leave that 0. So the next one we have that of 100 degree, we have 6.795 minus that of 0.02, then times over 1. We'll be looking at our T here in Celsius. So the next thing we are doing, okay, we'll look at the other ones. Let me try to do this thing so that we won't have much problem. I'm cracking my brain on it. Minus 6.35. We have 15, 0.15 all over 6.795 minus 6.35. We have 0.445 times 100 over 1. So at the end of everything, let's see what we have. 0.15 times 100 divided by 0.445. So what we have is equal to 3.37 degrees Celsius. That's the temperature of that. So we got it rightly. This is the temperature when the resistance is 6.5 ohm is equal to what? Is equal to 33.7 degrees Celsius. So let's go down to the next one. The next one, which has to do with now the question we're solving. All this question we're solving will be in the description of the of this very video, so that you will look at it clearly. Perhaps if you're not seeing this clear, and if you're joining for the first time, we encourage you to subscribe and then share. Encourage you to watch to the end so that you'll be able to understand how to handle some of these problems. And there's some other video that will be coming up at the end of the this very video, so that will also help you to go through to know more about the thermometer and its temperature and its measurements. So let's continue. The last one we have here is a constant volume gas thermometer records a pressure of 240 millimeter mercury at 0 and 280 millimeter mercury at 100 degrees Celsius. Calculate the room temperature when the gas pressure is 250 millimeter mercury. So just like what we have done before, the formula seems to be the same. Here we have, is it pressure? We're talking about pressure now. P at the what? T, subtract P at 0 all over P 100 minus what? P 0 times over 1. So what do we do here? Our P T is what? Is what we have here. Is what we have. We said is 250. And then P at 0 will come here at 0. Is said at 240. 240. And then P at 100 we have 280 minus 240. So what we'll do that times 100 over 1. So what we'll do that will give us, this will be 10 all over what? This one should be 40. Yeah, it will give us 40. So this one, okay, 40 times. So what else are we doing here? We can cancel out. Then if we cancel out, let me use the calculator, please. 10 times divided by 40. That will give us 25 degrees Celsius. Oh my god. Thank you so much for being part of the class. Oh my god. Thank you so much for being part of the class. And if you're joining for the first time, I encourage you to subscribe and then make sure you share the video. If you have any question, just feel free to drop it in the comment section. I will respond to you speedily. Thank you so much.